So I want to do some analyzing of this before any further. I want to think about what I know about this function because it can make some of the rest of the stuff a little smoother. Okay.
Okay.
So first of all, I have y equals square root. I'm going to write it this way. I've got -1 times x minus 4 plus 1. So this is not absolutely necessary, but if you do understand transforming functions, this might make things go a little bit easier. Because of that, I know that my graph got shifted. Well, I gotta go in order from left to right. So I know it got reflected horizontally. That means it's going to go across the y-axis.
Okay.
And I know it moved right 4. And then I know it moved up 1. So I know that my graph looks like this.
Okay.
Okay, so that vertex point is the 0.41. Is that believable?
Yep.
Okay. That tells me that that domain makes sense. I could get that domain from that.
Okay.
But even more importantly, and importantly enough, I'm going to go ahead and change colors here. My range, and I'm going to be careful, the range of f. Do I know what that is? So I'm looking at the y-axis, going up. Is there a first point? Hit the graph. What's the smallest y value?
1.
Okay, so if I mark up, I like to mark up the y-axis. So I start at 1, and then we're using everything else, right?
Right.
So I go from bottom to top. The smallest y value that actually got used was
1.
And then we used all of the y values from there on out, right?
Okay, yep, that makes sense.
So I'm going to go ahead and go a step ahead. I don't know about f inverse, but I now know that the domain of f inverse has to be 1 to infinity.
Oh, okay.
And that tells me that for f inverse, I don't know if I'm going to need this or not. Sometimes I do. I don't remember if they make you think about this in this class or not. But that means that for f inverse, that's the domain. The x values are going to be greater than or equal to 1. And I may or may not need this, but I'm going to go ahead and write it down just in case, because that way I'm on this train of thought already. I may or may not need it, but if I've got it written down, then I don't have to go back on that train of thought again and just look at what I wrote. I know that the range of f inverse is going to be -infinity to 4.
Okay.
And that came from that, right?
Right.
And so I know that for f inverse, I know that my y values are going to be less than or equal to 4. Sometimes there are problems that occur that where we want to think about that. Like I said, I don't know if we have to worry about that right now or not. Okay. So we want to find f inverse. So let's go back up here. And so we're just going to go through the set of steps that we memorize about inverses. So we know that it's easier to go ahead and use a y instead of an f. So I'll break this into steps. I could combine these steps, but so step 1, I'm going to go ahead and change f of x to y. Okay. So I change f of x to y, and then I switch my x and my y's. So wherever there's a y, it becomes an x. Wherever there's an x, it becomes a y. And let's make sure my square root doesn't have too much in it. Right at this point, I now have the inverse. I have the inverse function.
Okay.
It's just not written the way I would like it to be. So now we want to solve for y. So I want to get y by itself, so I'm going to attack this thing from the outside in. So first of all, to get rid of the +1, what do we do to both sides?
Subtract 1.
So I'm going to go ahead and just write that in just for fun. So those cancel each other out. So now I need to get rid of the square root. So I do what to both sides?
Square both sides.
And I'm just going to leave this. Actually, it's perfectly fine and maybe even easier to leave that.
Okay, yeah, you can just like write that and it'll be okay.
Mm-hmm.
All right.
Because we're going to end up with vertex form for a parabola, right?
Right.
So let's get rid of the 4. What do we do to get rid of the 4?
Subtract it from both sides.
So I subtract 4 here, subtract 4 here. So now I have x minus 1. So obviously there's little places where it's easy to make mistakes. Here's one of them. Don't let that negative disappear right now.
And then do we have to divide to get rid of the negative?
Yep, we'll divide. You know, it might be easier to multiply because dividing by -1 is the same as multiplying by -1 because
Okay.
-1 is its own reciprocal.
Okay.
I'm going to take that -1 times, but I had x minus 1 quantity squared minus 4. So y equals negative x minus 1 squared plus 4.
Okay.
We'll just rename it.
Oh, okay.
But now I want to think about it and make sure it makes sense and see if there's any little details that we need to finesse. So I want to go back to this picture. So you can see what I'm pointing to. Okay, so negative x minus 1 quantity squared, that means my vertex was at 1, 4, and my parabola is opening down. So if I have a 0.14, if I have a parabola and it's opening down, I'm going to cheat, plug 0 in, I get 0 degree, I think. So I have a parabola like that. I know that the line y equals x should be a mirror image for my function, for my inverses. And they both need to be functions. They both need to be one-to-one functions. And so I think that you can see that if I take this piece of the graph that is smaller than 1, if I take away the left-hand piece of the parabola, do you see they now look like they're mirror images of one another?
Yeah.
Okay. Across the orange line.
Yeah.
So that's something you've been thinking about, is making sure that they look like they really are mirror images of one another.
Okay.
With the right line. So that means you're folding the paper on the orange line, and they should match up.
Oh, okay. Sweet.
Okay. So now, we already figured out this thing about the domain,
Mm-hmm.
and it makes sense. So your question about domain in this case was, do I keep the left-hand side of the parabola or do I keep the right-hand side of the parabola? But the original function already told us which one to keep because we looked at its range.
Oh, okay. So for all of these, should I do like the range part first and then figure out the inverse? Like that'll help me, you
I
think?
recommend that.
Okay.
Yeah. That's what I would do.